This is sections 3.5 and 3.6. This is part 2. Okay. We are being asked whether a particular graph is a function. We're supposed to give the domain and range. Well, here's our graph. Okay. I'm going to kind of do this twice. For the first part, I'm going to pretend that that dotted section isn't there at all. Okay. Now, is this a function? Does it pass a vertical line test? It starts off here. It squiggles around, but it gets pretty steep in here, but it still never doubles back on itself. So this is a function. Okay. Now, and it's going to be a function even when we extend this, right? It goes up forever, but, you know, it is still a function. So it's going to be a function even after we consider that. So for the domain, okay, and this is the solid portion right now. Okay, the domain, where is this thing located on the x-axis? It is located between here and here, which would be -2, comma, 1, 2, 3, 4, and brackets. Okay, now where is the range on this? Okay. It starts, the lowest it gets is down here, and the highest it gets is up here. Okay, start with your smaller number, which would be -4, and it goes all the way up to a +2. Okay, now like we said earlier, I'm going to consider this one now. So, if I can spell. Okay, so let's include the dotted section. It's still a function. Now let's give the domain and the range. So let's say, where is it on the x-axis? Well, it still starts right here, okay? But it continues to go up, and this arrow tells me it goes on forever. So it's going up, but it's still going out forever. There is no end on the right-hand side. So the domain for this one would be, it still starts at -2, but it continues to infinity. And like always, infinities get parentheses. Okay? Now let's talk about the range for this one. Okay? It still starts down here, so that -4 is the same. But it keeps going up, right? That means it never ends on the y-axis. You could extend it up forever, so it's an infinity on this side as well. Okay. So let's talk about function notation. This is read, it looks like this, f of x. It's not multiplication. I'd love for it to be multiplication, but it's just not, okay? F of x, you could also have g of x, h of x, and so on. These are just sort of identifiers. They all mean more or less the same thing. This will be a lot more clear in a bit, okay? F of x is like y, but it means a little bit more than y. This is the kind of situation where, you know, a square is a rectangle, but a rectangle is not a square. If you see y, you have a graph, you may or you may not have a function. If you see f of x, you know you have a function, okay? You can always change f of x to y, but we cannot always change y to f of x, okay? Any function, and this one's called g of x, same idea, you can graph any function by using y and graphing as usual. So if I want to graph this function, really what I'm going to graph is y is equal to 4x minus 1. Now this is already in slope-intercept form, okay, which is y equals mx plus b, so we can read off our slope and we can read off our y-intercept. Our slope is going to be 4, and our y-intercept is the point 0, -1. This number tells you always where you cross the y-axis. So that's going to be right here. Now the slope of 4 is 4 over 1. And so we use rise over run. We're going to go up 4 and then run 1. And remember, you can keep doing this as many times as you'd like. Go up 4 and over 1 and keep generating points. So your graph looks like this. Okay? So let's talk about how we use function notation. Okay? You've actually done problems like this a lot. When you first started doing algebra, one of the first types of problems they made you do is say, okay, evaluate this if x is 4. You'd plug in 4 for x, do the arithmetic, and find the answer. That's exactly what we're going to do here. Okay? You're given these two functions. Now, this would be in the instructions. These are not forever definitions. This would be like problem 1, and these would be part A, B, C, D, and so on. So these are given to you. Okay? Evaluate each of the following. That means we're going to plug in a number and get a number answer. F of -3. What this is telling me to do is to go find the function we call f, which is going to be this one, and then take -3 and plug it in for x. So f of -3 is -3 times -3 plus 4. Use your order of operations and multiply first, and you get 9 plus 4, which is 13. Okay? Part B. Find g of 10. This is your g function right here. Okay? And so we're going to take this function and we're going to plug in a 10 for x. Now, one of the trickiest things about this is a lot of people mess up plugging in right here. Okay? This is going to be, this literally means -1x squared, correct? If there were a 2 here or a 3 here, we would not have any issue with this. It's just that negative. If you follow your order of operations, you square before you multiply. Okay? So I'm going to write in the -1 here. This is -1 times 10 squared plus 4 times 10 plus 1. Okay? So this is -1 times 100 plus 40 plus 1. So I have -100. I'll go ahead and add these to plus 41. And this gives me the answer of -59. Now what happens if you had plugged in the negative here? So you don't want to do this. If you accidentally put the negative on the inside, this is -10 times -10, which is +100, plus 40 plus 1, which gives you 141. And this is not correct. This is a very common mistake. So if you see a negative just in front of a number, you may want to go ahead and write in the -1, just so you can remember that it's there and you don't make this kind of mistake. Okay, now you're not always going to have to plug in numbers. This is saying g of k. This tells me to go find my function g and then plug in k for x. This is simply a variable change. Okay, so what I'm going to do is I'm going to come up here, and everywhere there is an x, I'm going to write a k. So this becomes -k squared. I've just plugged a k in for x, plus 4k, and then plus 1. And this would be your answer here. Now I know this seems silly, but this kind of thing, plugging in variables and things, this is an easier example of something like this. And this kind of stuff comes up a whole lot in college algebra. So you need to get practice with this stuff now. Okay, this one says to take 3t minus 2 and plug it into f. Now I'm going to recopy my f function right here. so we can see it better. Now, what I'm going to do is I'm going to take all of this and plug it in right here. Now, this can, you know, a lot of people can understand the first three here, but this one messes people up. If you start to get confused, you can think of it like this. Think of that x as a box that you're going to fill in. Okay? And then what we're going to fill in right there is 3t minus 2. Okay? So this is, I take the negative 3, and instead of multiplying it by x, I'm going to multiply it by 3t minus 2. And it needs to be the whole thing, so you need to keep those parentheses around. And then I have the plus 4. An incredibly common mistake is to leave off the plus 4. Students do the hard part, and then they just stop. So don't do that. Now, we are going to be asked to simplify this, so go ahead and distribute to get negative 9t plus 6 plus 4, and this is negative 9t plus